Hey Stewie, have you ever wondered how computers align really long strings of data, like DNA or text, without using up all their memory?
I've thought about it a bit, Brian, like finding differences between two versions of a document. I imagine that takes tons of memory for really massive ones.
Exactly. That's where something called Hirschberg's algorithm comes in. It's a clever trick I use for sequence alignment.
Okay, sequence alignment. So it figures out the best way to line up two strings of letters, right?
That's it. Imagine I have two long words, say, science and scenery. I want to find the best way to insert gaps so they line up perfectly, minimizing differences.
So far, so good. But you mentioned memory. How does it save memory compared to just comparing everything?
Well, instead of building a giant table of all possible matches, which would get huge, I use a divide and conquer approach. I work forwards and backwards from the middle.
Forward and backward. That sounds like a confusing puzzle to me.
Can be. I find the best match for the middle part of my sequences. Then I use that as a pivot point. After that, I solve the problem for the first half and then for the second half independently.
So I guess I don't need to remember all the details from the first half when I'm working on the second, because I've already fixed my middle point.
Precisely. I only need a little bit of information at each step, not the whole big picture at once. It's like finding the exact middle of a long zipper, then zipping up each side separately.
Ah, I think I get it now. It's about breaking down a huge problem into smaller, manageable chunks and not holding all the intermediate steps in memory. That's really smart.
That's exactly it, Stewie. I use it because it's super efficient when I'm dealing with incredibly long sequences. Does that make sense?
Totally, Brian. I can see why an algorithm like that is so important for things like genetics and data analysis.